All right, angles, triangles, and parallel lines. Oh my. For those of you who get the joke, awesome. All right, so let's start with some triangles. We have types of triangles. We have three main types we're going to talk about. Scalene is a triangle with no equal sides, okay, and no equal angles. So that's a kind of a big idea. And so it can have some very odd shapes. So all of the angles are different and all of the sides are different. That's a really important piece to note. Isosceles, tricky spelling, but it's a triangle with two sides equal and two angles equal. So we mark equal sides usually with a little single tick, and then we can mark angles here. I'll put a little dot in both. So you'll notice those two bottom angles would be equal and the two opposite sides would be equal. And then lastly, an equilateral triangle is a triangle with all sides equal and all angles equal. So we could put a little sign like that and put a dot in each corner to represent that those angles are all the same and that all those sides are all the same. So if you want to try this, this is a little at-home task you can do. I'll do it with an animation in a minute. Just take a piece of paper, cut any triangle you want in it, doesn't matter on the size. If you put a mark in each corner, and then tear the corners off. And what we're going to do is we're going to rearrange them, and we're going to see something along this lines. Let's go to the, there we are. So there's my triangle, and if I grab that corner and I drag this around, okay, there's the three pieces. There's a green, a yellow, and a light blue, and you'll notice they make up half a circle. Well, a full circle is 360 degrees, half a circle is 180 degrees, and no matter what I do to this triangle, okay, you'll notice as long as I keep a triangle, I gotta stretch it way over here, those three interior angles always sum up for 180 degrees. And that's our key piece of information we need. Okay, so the sum of the interior angles of a triangle is always 180 degrees. So the hardest part I find for people in this section is to not be lazy and to write down a little bit of information. And this is a big line, so find the missing angle in each triangle. So this line right here, A plus 60 plus 88 equals 180, communicates to someone that you know exactly what you're talking about. Okay, from there you can solve it. So we add these together, 148 equals 180, and then A must equal 32 degrees. Okay, then you can do the same with this triangle that's in a very odd shape. We would say B plus 12 plus 16 equals 180. Add the two numbers together on the left-hand side for 28. Subtract 28 from both sides, and we would get 152 degrees, and that would be that angle right there. Okay, so complementary angles, they sum for 90 degrees, so that's a good word to know, complementary. It'll be referenced a couple different times. So the equation looks like this: G plus 65 equals 90. Okay, and the little square here, if you're not familiar, the little square there represents 90 degrees. So if we solve for G, we get 25 degrees. So we would show 25 degrees. Sometimes you draw a little connector line in there, and there's 25 degrees. And that's a complementary angle. The next one you want to know is supplementary angle. So supplementary sum for 180 degrees. So this is going to be Z plus 128 equals 180. Okay, and again, that line communicates you know what you're talking about. So that's an important line to sort of buy in on. If you just write down the answer and you get the incorrect answer, there's not much anyone can do for you. So if we subtract 128 from both sides here, we get 52 degrees, and that would be that angle right in there. Okay, so notations for triangles and different angles. So if we have something simple like this triangle, we can get away with this notation. So angle, this is the symbol for angle. Angle A, B, and C. The little triangle is a symbol for triangle. When we get to more complicated shapes, we'll move into something like this. Okay, and so this is the angle formed by going from A to C to B. So if you started at A, went to C, went to B, you will notice the angle right in here is the one we're looking at, and that's that central letter. That's another way to think about it. Okay, so if we go back here and let's fill in the missing pieces we have here. Angle B, so if this one here is 90 degrees, angle A is 30 degrees, then the missing angle here would have to be 60 degrees because all three of these together would have to be 180 degrees. Okay, so now angle CBA, let's change color. So if I go from C to B to A, it's this angle right here, which we've already found is 60 degrees. Okay, so let's carry on. All right, so now find angle ABD for the following triangle. Now there's a couple ways to do this, and you're going to see a couple neat connections. If we just approach this as a triangle, let's call this let's put a little symbol in there, a little alpha. Okay, so we would say alpha plus 84 plus 32 has to equal 180 degrees. So that would be a little alpha plus, what's that, 116 degrees equals 180. So little alpha would have to equal 64 degrees. Okay, so we could put a 64 degrees there. Now if we looked at this angle on the outside right here, we would see that's a supplementary case, so we could say this is, let's give it a symbol of a beta. It's like a B with a stick. So the alpha plus the beta has to equal 180 degrees. Well, we already know alpha is 64 degrees, so we can solve for that missing beta, and we get 116 degrees. And now for those people who are paying attention, you'll say, well, hey, that 116 degrees also showed up here. It's also the combination of these two. And that is a great observation. That's a neat shortcut. So for exterior angles of triangles, let's see if we have this one here. There we are. Okay, so now if I grab this top B here and I move it around, you'll notice that 72 and 73, they should add up for 145. It's just a little glitch in how the computer's rounding off. Okay, but those two angles here, whenever the green and the blue, those two will be equal to the exterior angle. And if you can make them move, if we click the little button, you can see those pieces slide over and fit right in there. Okay, so if we reset that, I can move this triangle around to here. Let's move them one more time. You see those pieces, whoop, they bounce, and here it comes. And there it fits, okay? And that's the relationship among the interior and exterior angles of a triangle. Okay, another way of looking at it, if we grab these three pieces, if I take A and I just slide it over here, and I grab B, slide it over, and then flip it, so that angle B is actually in the right orientation, you'll notice it makes a perfect match for 180 degrees. So we can fill this in at 180 degrees. Okay, angles and crossing lines. So you might know this as opposite angle theorem, or OAT, depending where you are. You could also do this with supplementary angles, which is the 180. So if you looked here, let's use our little alpha friend again. You could say alpha plus 35 equals 180 degrees. So the little alpha has to be 145 degrees. Okay, and now you could continue doing that all the way around. Just keep doing supplementary angles. Okay, so this would end up being 35 degrees. This would be 145 degrees. And what you should notice is the opposite angles end up being the same. Okay, so after a while you just learn whenever two lines cross, when you can do the opposite angle across from it, you can just fill it in pretty quickly. Okay, parallel lines. Parallel lines have little arrows on them like this, just in case you can't see them, that indicate they are parallel. The line AF that's crossing this is called a transversal, and we'll be looking at a couple of different patterns. You may have seen these before. So let's take a look. HBA is 110 degrees. So from H to B to A, this is 110 degrees. Okay, so now you can use a combination of supplementary angles and opposite angle theorem, and you can fill in missing pieces. So you could say this is 110 degrees from opposite angles, and then you could say this angle up here is 70 degrees from supplementary angle theorem, and then you're back to opposite angle theorem. Now, if you want to do a quick check, when you add up all of those numbers, the two 110s, the two 70s, you should get 360 degrees, because to go all the way around here is a complete circle. Okay? So now, angle GEF is down here on this other bottom line. Now what we find with, and I have a good animation for this, is that because these two lines are parallel, we can take all of the information that's on the top parallel line and we can basically slide it down. So this angle right here would be 110 degrees. These both would be 70 degrees and 70 degrees, and this one here would be 110 degrees, because the line is crossing those two parallel lines in identical fashion. If I added a third line that's parallel like this, I could copy all that information down once again. It would be identical. Okay, so now let's take a look. There are a couple things we're going to call corresponding angles, and we make something what we call an F pattern. Okay, so corresponding, if you think of an F pattern, it looks like that. Okay, so corresponding are these. These guys are in the same locations. Okay, they're below the parallel lines. You'll notice above, we'll go to a light green. Ooh, that didn't go very well. Those guys are in the same locations. Okay, so you could also flip the F the other direction and you would have the exact same effect. So that's what we call a corresponding or F pattern. Okay, I'm just going to back that up, get rid of some of my highlighter. Okay, now we also have alternate angles, which is a Z pattern. So that is a Z pattern like this. Okay, and I think of it like the armpits of the Z. So this armpit and this armpit will be the same. Okay, and that's another pattern we can take an advantage of. And then our last pattern is a C pattern, and it's the sum of the co-interior. Okay, so if we make a C like this, you'll notice the two numbers inside the C sum for 180 degrees. Okay, so we have a little geometer sketch pad here. Let's see if it'll open in the right location. C. Nope, wrong one. Did I get it? No, wrong one. Let's close that. No, I don't need that. And open the right one. There it is. Okay, let's get it inside the viewing box. Okay, so here is what I was just talking about. There's the four angles. The opposite angles are in the right colors. So if we slide that up, you can see it's exactly the same. Okay, so now even if I change this transversal, I can change the angles around, make them slide it up. They're going to be exactly the same. Okay, so let's go to the next piece. So let's actually solve a problem. So find the missing angles. So you'll notice right away there are two parallel lines and two different transversals. That's really important. The technique I use to solve these problems, I'm not really good at memorizing things, so I tend to write down a lot of extra things. So for example, I would fill in, starting at this 86, I might fill in some of this missing information. I know the opposite angle is 86. I know from supplementary angles that this would have to be 94 degrees. So these would be 94s. Okay, and then I would also know from the corresponding, that's the parallel lines, I could fill in an 86 down here. I would fill in a 94 down here. And all of that is just comfortable with that idea that the angles on the top line can slide down and join the bottom line. If you have to, you could even extend this to make it easier to see. That would totally be acceptable. Okay, I'm going to jump over to the 124. I know this is the opposite angle, so it's 124. I know the supplementary angle of this would be 56. 56. And again, I can slide all that information down using corresponding angle theorem. So G is 124. This is 56. And now lastly, I want to try and find this K. Well, I can see that I have a triangle here, and I have K plus 86 plus 56, and I know that the interior angles of a triangle all sum for 180. So this is 100, oops, I better backtrack here 1 second. So 80 plus 50 is 130, 136, 142. Okay, and then I'm going to subtract 142 from both sides, and I end up with 38 degrees. So this is 38 degrees. So I found all of the requested angles that I was asked for. Okay, this one's going to merge some of our triangle knowledge and some of our algebra skills. Okay, so I know these three angles have to sum for 180 degrees, so I'm going to write it out. Those three angles all added together have to equal 180 degrees. I'm going to collect like terms, 2x, 3x, and 5x, that's 10x. On the left hand side I've got 60 minus 30, so I'm left with positive 30. Okay, and then let me give myself a little more room here. I'm going to subtract 30 from both sides. I'm going to divide both sides by 10. That leaves me with an x value of 15. Now if I go back up here, I should be able to use that 2 times 15. This would be 30 degrees. This would be 5 times 15, so that's 75 minus 30. This is 45 degrees. And then down here, this is 3 times 15 plus 60, so that is 30, 45 plus 60, that is 105. And if I do a quick check, 105, 150, 180, I get the sum of the interior angles to be 180, which is what I expect. Okay, a couple questions to try. Thank you for tuning in.